Sales and operations planning is a process that organizations go through in the tactical time frame, usually 6 months up to 2 years. The purpose of sales and operations planning is to translate a forecast for product demand into the requirements for resources such as labor that need to be used to meet that demand forecast. This example has assumptions that are in the aggregate 2 Excel file. At the top of the file, we see a demand forecast for a 6-month period. This forecast was previously developed from data for 3 years of seasonal demand for a product. We see a lot of other assumptions here listed in the file that are going to be important for translating this demand into a forecast for the labor required and also into a budget and a unit cost estimate. Some of the more important assumptions are the labor productivity per hour. This tells us how many units of the product can be produced for each hour of labor that's employed. Clearly, there may be other resources such as machines that are required as well, but this particular sales and operations plan is concerned with a labor forecast or schedule. There are several other assumptions related to the hourly and overtime rates for labor, the regular hours that workers are employed per month, and the maximum hours that workers are able to be assigned as overtime per month. Worker retention is the number of workers that are carried over from one month to the next. The utilization rate will be important to determining the total number of workers needed, because the utilization rate captures time for which employees are paid but not actually actively engaged in producing output. Vacations, breaks, and other activities that aren't directly producing output are examples of factors that are considered when developing a utilization rate. The last 3 assumptions are related to the cost of hiring new workers, firing workers, and there could be some limitations on the maximum number of workers that are hired per month. Anytime we solve the sales and operations planning problem, we need to think about some key elements of a constrained optimization problem. Constrained optimization means we're trying to achieve a goal. And in this case, the objective or goal is to minimize total cost over the 6 months. We can see that there are 4 rows in the model that contain the decision variables in the problem. The decision variables are the values that can be adjusted by the managers. In this case, managers can choose to hire workers each month, fire workers each month, assign overtime hours each month, and then the manager chooses the number of units to be produced. Typically, what is the best way to build the template is simply to enter some starting values for the decision variables, because then when the formulas that refer to these variables later in the spreadsheet are created, they'll populate with numbers. So these are just simply some starting values. So we know the objective will be to minimize cost. We'll have to build the cost model. And we know the decision variables. What we need to do now is build a workforce and capacity model that translates the decision variables and the workers into a production capacity for each period. First of all, at month 1, we have a beginning assumption about the number of workers that are available. In this particular problem, we know that there are 40 workers available. The available workers, then, at the beginning of each month, will be the beginning workers plus the workers hired minus the workers fired in each month. The regular labor hours worked will be the number of available workers times the regular hours per worker per month. In this case, the regular hours per worker per month is 160. The regular labor hours available is different than the regular labor hours worked because of the utilization assumption. In this case, we assume that workers only produce output during 80% of the hours that they work, and this is because they have breaks during the hours that they work, and could also be due to things like paid vacations, as well as other tasks that just aren't associated specifically with producing output, such as cleaning or maintenance. So we multiply the regular labor hours worked times the utilization assumption. Maximum overtime hours is not necessarily the hours that we worked, but it will be required to create a constraint. So if we have 45 available workers, we would multiply that times the maximum overtime hours per worker within each month. The total labor hours available considers both regular labor hours available and the overtime hours assigned. In this case, we'll add the overtime hours assigned, which is a decision variable, and the regular labor hours available. We make one assumption that simplifies the analysis, and that is that the overtime hours in this case are not subject to the utilization assumption, but that could clearly be adjusted if we felt like they should be subject to the utilization assumption. Notice that we're not adding in the maximum overtime hours because managers may not choose to assign the maximum overtime hours. We're adding in the overtime hours assigned in the decision variable, and keep in mind that the 100 that I have in the worksheet right now will be adjusted when we look for a solution that minimizes cost. The total labor hours available is subject to the labor productivity assumption, and this determines the number of units that can be produced during the month. Here we simply multiply the total labor hours available times the labor productivity assumption in units per hour. The excess capacity is the number of units of capacity that are not being used in the current month for production. This would be the production capacity minus the units produced. When I click Enter, this is going to display a negative number. The negative number would not be allowed once we've actually solved the problem, because we'll ensure that the excess capacity is at least greater than 0. In this case, we can copy all of these formulas except for the beginning workers formula over to month 6. We need to complete the beginning workers formula for month 2 and beyond. This requires us to use the retention assumption. The beginning workers for month 2 is equal to the available workers for month 1 times the worker retention assumption. In this case, the assumption is 90%. I would then copy that out through the remainder of the 6 months. After completing the workforce and capacity model, we'll complete the production and inventory model. The beginning inventory is an assumption based on an inventory account at the beginning of the period. And in this case, the assumption is that there's 100 units of beginning inventory available. The units available to meet demand is the beginning inventory, plus any units that are produced during the month. The units produced during the month are a decision variable. The ending inventory then is the units available to meet demand minus the demand for the month. The demand for the month is the basis for the model, and it comes from the seasonal forecast for demand. The bottom 2 formulas can be copied all the way over to month 6. The beginning inventory assumption for month 2 and beyond is that beginning inventory for month 2 is equal to ending inventory for month 1. And that would be copied to month 3 up to month 6.